Good morning. If we could please take our seats. Would you do me a favor and close the lid on my computer so I'm not burning my battery needlessly? Thank you. I meant to close it and I forgot. So we have reached the third and final day of what has been a really interesting and I think constructive meeting of the Moon Village Association 6th annual workshop and symposium. I appreciate the engagement of all of you. For an event that will begin shortly after the luncheon. And I wanted to make a logistical announcement that National Space Society Space Settlement Summit, if you are signed up for that event, then after this meeting concludes, so basically we'll finish up at lunch, you need to go out to the desk outside, get your summit, get it. They've got a nice NSS bag that is intended to promote donations and memberships and advertisement, a walking billboard. But it also has a program for the SSS in it and so on. My announcement. So during the 2 days, we've had a series of presentations with an emphasis on lunar construction and lunar development this year, from NASA, from industry, a lot of focus on the robotic systems that will make lunar development and lunar construction feasible. Things like the Tux rover here in the corner. I do not yet see Gary Barnhard, but Greg is here. He's coming. Okay, very good. Yesterday, we had a series of breakout sessions, and we're going to start this morning with a quick readout on the breakout session. Architect Working Group readout, that was with an emphasis on the study, which the Moon Village Association is doing, called OASIS 2045. That is a focus study of the first permanent human settlement on the moon, targeting the year 2045 and then looking back towards the present day from that perspective. We're going to talk a little bit more about that at the end of this session. Next, I'd like to introduce Alice Bienhoff with their product called the Lunar Commerce Portfolio as of this meeting. So Alice, if you would be so kind. Use my time as an example.
You mean be long? So if we could.
One more thing, sorry. Don't fall on the steps. Nobody's gotten hurt yet?
I promise. So if we could have the slide. Should be 11 a.m. event wrap up. Are we doing the wrap ups? Yeah, the wrap up. Yeah. John doesn't know his own schedule. The file name was 11 a.m. wrap up. It's at 9 o'clock. So this is really Derek's endeavor. Derek started this activity, the Lunar Commerce Portfolio, through the Moon Village Association and made it happen. So Derek is really the driving force behind this. No coffee. So we did have the kind of workout, our breakout session we're looking for yesterday. We got comments, we got questions, we got suggestions. We got everything we wanted, I think, out of the breakout session. We need the Jeopardy theme song here. And no, we're not doing 12 slides. Great. Okay. Forward, forward, forward. This was the teaser from yesterday. The comments are in the back. Bingo. So we had about 16 at our breakfast session, and we had about 9 in our breakout session yesterday. And these are the questions that were asked. The top 3 kind of say, here's another scenario to look at. Here's another set of markets, or the size of the markets to look at. And is the U.S. Space Force a customer? Partially. We had one market team that where the military was explicitly defined as a customer. Changed some words to be more acceptable to a broader cultural community. It was cited as an excellent framework for future work and analysis by several people. It was accepted as a major asset. Two organizations have volunteered to possibly help use this and expand it and make it better. That's the NSS and the Aerospace AIAA activity being led by Dennis Paul. Offered because they have to go back and get confirmation. So, but that was appreciated. What about the supporting ecosystem, i.e. the biome? What do we need besides people and technology at the moon? Insects, pollinators, flowers, plants. What do we need there to make it a livable place? And where would that be? We had what looks like an issue with our energy market team, because as activities got larger, power demand went down. We know that's probably not true. I.e., how do we support the common functions that you see in a community like police, fire? How do we support that? Where does that revenue come from, and where does it go? That was probably in our overhead number that we used as a defined as a factor. We obviously need to update our slides to reflect what's in the Excel model. We had some late breaking news and analysis so some of those didn't get incorporated into what we shared in our breakout. And also, we looked at 2 different pricing structures for launch to Earth, which then ripples throughout the market sectors, and MT9 or MT2 and MT9, all the other market areas, should reflect that difference of launch price from Earth in what they need as revenue to generate, to make money in the long run. So how does launch price affect the revenue that is earned on the moon? There will be an impact. And then we had a set of priority external drivers that drove our scenarios. What is the priority of those external drivers? What's the most important thing to attack first? What's the most important thing to take on second that will allow this economy to materialize. Positive reaction to our MOU with Bocconi, the school in Italy that will be taking this on as a way to work this and manage it and make it better and improve it and track it over the years, because we laid the foundation for it to be improved over the future. What about how do we do version control of our model? And really it's there to be used by people and modified by people who are using it to their needs. We will retain some kind of internal management or version control as it gets updated, but as it is, it's free to use it any way you see fit. So we won't control how you use it, we'll control how we release it. And then I would have liked to have had another 3 to 6 months for quality checks before we came out with it, but we had like 3 days. So we know there are issues, and we appreciate any feedback we get to make it better. And then Derek announced the user group yesterday in our overview session, and we've had 14 people sign up already to join a user group to help mature this, make it better, give us feedback, and just improve it for the community. So appreciate your input, your comments, your suggestions, and it will only be better with your help. Thank you. Which one's up and which one's down?
Could I have the Hanlon slides? So our next breakout is from the report is from the Lunar Governance breakout session. This was led by Michelle Hanlon. They had about a half a dozen or so folks. Top thoughts from that, and unfortunately Michelle cannot be with us this morning. She is hoping to join us by lunch. First, the idea that pretty inherent that the Outer Space Treaty is the short-term context and go-to international document vis-a-vis lunar governance. But it's a short-term solution, and the communities in space will have to go beyond the Outer Space Treaty. Lunar governance, there's the idea that lunar governance has to work from the bottom up, and that humans will be humans, and communities will just be, a nice turn of phrase, and we need to let them be. And that looking toward the future, all we can do with regard to governance is to try to provide guideposts. I think it's just this one slide. Is there another one? Yeah. Would anybody who was in the lunar governance team care to say anything about the conversation? Well, there is another slide. Okay, thought you said only one. Sorry. The challenges, different ideologies, freedom versus communal ascendance. Multiple communities on the moon would be good to great, and we would hope that they would support each other. But for a time, communities will be guided by their international or national identities. Hope that they would assist one another, and that over time ideologies are inevitably going to clash. Question is, would one win out over the others? And that we can protect individual freedoms through a recognition of individual human rights, which is in itself a question of international ideology. Is this it? Is there any other? There is another one. So, baby step solutions, reviewing the UN Declaration of Human Rights with a view towards creating a declaration of the rights of humans living and working in space. I think for the UN, if you know the UN, it takes them about 6 or 8 years to organize a meeting. So I think this would take some time to accomplish, just my opinion. And we need to consider what additional rights should be supported. The right to leave, the right to oxygen being examples. and what are the baselines that all countries could agree upon. And it might be useful to have a shadow COPUOS, the Committee on the Peaceful Uses of Outer Space, which is currently made up only of national actors, and the shadow COPUOS that would comprise non-governmental organizations and industry actors. Next, please, if there is one. Okay, good. So, is there anyone here from the governance who attended the governance breakout session who would care to offer any additional thoughts from what Michelle? Okay. Okay, very good. And lastly, Rob Mueller. Rob, if you'd care to say a word or two. Rob has no slides.
Okay, good morning. We had a good afternoon yesterday. It's the Analogues, Moon Village Association Analogues Working Group. We didn't have a meeting like the other working groups did. We just had an actual hands-on telerobotic experience. Anybody in this conference was welcome to sign up and operate a rover in Hawaii. And it's operated by PICES, the Pacific International Space Center for Exploration Systems. They were gracious enough to volunteer to do this, no cost. And we were also able to test a new site on the Kona side of the Big Island of Hawaii called NELHA. And I forget what the acronym stands for, but it's to do with renewable energy. They have a nice site by the airport on Kona there. National Energy Lab Hawaii Authority, and NELHA was gracious enough to host us with power, internet, logistics at no cost. But what was in it for everybody is we got to test out a new site in Hawaii, which will be the future, because Mauna Kea is getting a little contentious with the indigenous protests. So we're gonna move away from Mauna Kea down to the coast to NELHA. But this is a new test site that's available for everybody, and PICES was interested in advertising that to the community, and that's one of the reasons why they agreed to host this. We did have 15 people sign up ad hoc. I think it worked very well by being in the lobby. Everybody was able to see. We projected the image on a wall, so people that were not driving could experience it as well. I think it was successful. We had 15 people have telerobotics experience. If you were one of those drivers, can you raise your hand, please? Okay. So now I think it was successful. Now I would like to invite you to tell if you thought it was a good experience or not, just very quickly. But I thought this was very successful because it was cheap. All you needed a laptop and an internet connection on our side. And we have the software worked out. We had no technical glitches. And I think we can do this. Professor from Italy, who was interested in doing it very soon with his students in Italy. So then the question for John Mankins and the MVA leadership is, when can we do this again? But does anybody have anything they'd like to share on their telerobotics experience, good or bad? Easy to drive? Few commands? Okay. All right, so I think overall we had a good experience and we'd like to do it again. Thank you.
Thank you. Our next talk this morning will be by Zoom. So Bernadette has now joined us. Bernadette Detera, who's a member of the MVA leadership. There she is. I see her on Zoom. I don't see her. No, you're not.
Excellent.
You're not
Hi,
on yet.
John. Can you hear me okay?
Yeah, good. Now you're on. Now you're on.
Okay, perfect. All right. Can I start my presentation then?
Yes.
All right. Yeah, absolutely great. Good morning to all of you over there. My name is Bernadette, and unfortunately, I couldn't be there in person, but I'm very excited to share one of the activities of the Moon Village Association, one of the initiatives that we're having, and we are really happy to invite all of you to join this as well. So let me just share my screen. All right, I believe you can all see my screen very well. So again, it's a pleasure to meet all of you virtually. My name is Bernadette Detera. I'm the Global Network Implementation Support Officer of the Moon Village Association, and this time I will be presenting about the PromoMoon initiative, which is essentially a capacity building activity for new space market development on lunar technologies. So this initiative is a joint collaboration between MVA and Yuzhny State Design Office from Ukraine, which I will be introducing in more detail later on. And this initiative is really in honor of Dr. Alexander Detera, who is the general designer and general director of Yuzhny State Design Office. So this is the inspiration for this initiative. And what is this really about? So this PromoMoon initiative has several objectives, and its main objective is to inspire the next generation. So to inspire the Moon Village generation, including initiative groups, enthusiasts, startups, to develop their own lunar technologies for sustainable lunar activities. So this initiative is a way to facilitate capacity building for new space market segments and the young Moon Village generation. And also, this aims to provide support in terms of proof of concepts, advancement on increase of engineering design maturity of novel lunar technologies that these enthusiasts and young professionals are proposing. And of course, this aims to have to help us expand international cooperation towards future sustainable lunar activities. So this initiative started last year, and we are very happy to announce that we are having a second installment of this great initiative. So this is for 2023. We have a second installment, and essentially for this initiative, participants and winners will receive free of charge evaluation and free of charge B2B mentoring from experts, and also we are offering an opportunity to present these novel ideas and technologies during the International Astronautical Congress in 2023 outside the typical selection process. So this is happening for next year during IAC in Azerbaijan. So we have several categories for this. Teams, startups, young professionals, and students can submit a proposal on a novel lunar technology under certain categories: transportation to and from the moon, transportation on the moon, power systems, and so on. So with this, anyone can apply essentially from anywhere on Earth. So startups, SMEs, new space companies, teams of students, and young professionals. And this is the timeline. So we call for proposals, and we invite you and your colleagues and your network to submit a proposal. The deadline has been extended until December 24th, just before Christmas this year. And after that, we will be evaluating the proposals and selecting the top 10 finalists, and then finally having a second round of evaluation to determine the top 3 winners of this initiative. So the 3 winners will be receiving the B2B mentorship that I was referring to earlier. So again, if any of you are interested to submit a proposal, we highly encourage you to visit our website and submit a proposal. You can also use this QR code to directly see the webpage containing all of the details about this really great initiative. And before I proceed to introducing Yuzhnoye State Design Office in more detail, I would like to share a video of how it went with our pioneer first year of this initiative. So let me just share a video. I hope the sound is let me just
The first PromoMoon initiative, or Moon Village Generation, in honor of Dr. Alexander Detera, an outstanding scientist and manager, was organized in late 2021. Along with the well-known international space projects, Sea Launch, Land Launch, Dnipro, Cyclone 4M, Antares, Vega, Dr. Detera initiated projects on near and deep space exploration, in particular the exploration of the Moon. "15 teams from 10 countries took part in the PromoMoon initiative, including 4 startups, 5 teams of young engineers and scientists, and 6 student teams. All participants received professional expert evaluations, and the finalists took part in online mentorship sessions with a team of international experts to get live review of their projects with recommendations on their improvement and further steps of implementation. Today, we announce the opening of the second season of our PromoMoon initiative.
I would like to express my gratitude to the Moon Village Association for the unprecedented popularization and promotion of the ideas of lunar exploration, as well as active efforts to involve new professionals and enthusiasts in the search for effective solutions to applied problems of Moon and cislunar space exploration. Our joint PromoMoon initiative is ideally suited to these tasks and provides a real opportunity for young enthusiasts to receive professional review and recommendation for the development of their own projects. Our goal is to expand international cooperation and inspire the current generation of young engineers and scientists, students and enthusiasts to develop ideas, transform them into relevant and sought-after products with their further integration into large global projects dedicated to exploration of near and deep space. With this address, I am pleased to announce the start of the second PromoMoon initiative for Moon Village Generation in honor of Dr. Alexander Detera. Yuzhnoye State Design Office, together with the Moon Village Association, invites everyone to take part in this initiative. Good luck.
all right. So I hope you were able to hear all of that clearly. And we invite everyone. We invite you to submit a proposal and join this initiative, the PromoMoon initiative for 2023. And if you have any questions, I will be more than happy to answer them about this initiative as well. So before I officially end, I would like to take this opportunity as well to introduce Yuzhnoye State Design Office in more detail. Some of you might have been familiar with their company and what their company does already, but for this symposium, MVA workshop and symposium, I would like to introduce Yuzhnoye to everyone. So let me share my screen again, and I hope you can all see it. So on behalf of Yuzhnoye, as you know, it is a very difficult time for them right now, and they could not join us today as well. So on behalf of them, I will be introducing their company and what their company does. So Yuzhnoye State Design Office is a high-tech Ukrainian company, one of the internationally recognized centers of aerospace engineering, with experience gained over almost 70 years of activities. For more than 30 years, Yuzhnoye has been an active player in the international space market. Participation in commercial projects brings the company more than 90% of the total income. Yuzhnoye is in cooperation with more than 100 international partners. Since 1954, in cooperation with academic, scientific, and industrial partners, Yuzhnoye originated numerous unique solutions, such as application of hypergolic propellants, an autonomous control system, pop-up launch, railroad launch, a unified satellite bus, and other breakthrough solutions. Over the period of almost 70 years of its activity, Yuzhnoye has developed 4 generations of intercontinental ballistic missiles, 9 types of space launch vehicles, 70 models of spacecraft, 100 types of liquid propellant rocket engines, and solid propellant rocket motors. Efforts of Yuzhnoye specialists have resulted in more than 900 missions of launch vehicles, more than 400 launches of in-house developed spacecraft. Yuzhnoye has taken and still takes part in international projects such as Antares, Vega, Sea Launch, Land Launch, and Cyclone 4M. And today, Yuzhnoye, in cooperation with the Ukrainian companies, provides a full cycle of development for all types of rocket and space technology. To implement domestic and international projects, Yuzhnoye unites efforts and serves as a gateway for more than 120 Ukrainian high-tech enterprises. Deep integration of Ukrainian international science, engineering development, and production provides world level of Yuzhnoye's products and services. And in frames of the crewed lunar program of 1963 to 1971, Yuzhnoye developed and successfully tested in Earth orbit the Block E rocket stage. Block E was the LK lunar module's propulsion unit designed for its soft landing on the surface of the moon and subsequent return of the near Earth orbit. As you can see here as well. So today, Yuzhnoye is developing a lander hopper for payload delivery to the surface of the moon. It can support multiple flights and soft landings on the lunar surface, moving a 50-kilogram payload for up to 20 kilometers. They're also developing a robocar, a device supporting operations on the moon surface, such as unloading, transportation, installation of the habitation modules and infrastructure components, and enabling scientific research, geological exploration, travel and tourism, as well as other activities. To add to that, they're also developing innovative water electrolysis technology to supply power to the lunar settlement and produce rocket fuel on the surface of the moon. The technology is based on a high-pressure membrane-less electrolyzer, allowing for safe electrolysis and accumulation of generated gases at up to 200 to 300 ADM without any compressor equipment. So you can all see it here as well. And Yuzhnoye is not only successfully running projects, but also actively developing future scientific and technological solutions for creation of the state-of-the-art and advanced technologies related to the exploration of the moon and deployment of a lunar settlement. And as I mentioned earlier, as I introduced earlier, Yuzhnoye is partnered with the Moon Village Association to hold the PromoMoon initiative for Moon Village generation in honor of Dr. Alexander Detera. Dr. Detera was Yuzhnoye's general director. With over 40 years of experience, he met a number of challenges in the aerospace industry, and his scientific achievements found their application in international space projects such as Sea Launch, Land Launch, Cyclone, Antares, and Vega. And in 2021, the command center of the future launch pad of the Cyclone 4M site in the province of Nova Scotia was named after him as well. Yeah, you can see the Cyclone 4M site here as well. And lastly, Yuzhnoye is directly involved in the organization and implementation of the PromoMoon initiative, as I mentioned earlier. And one of Yuzhnoye's main responsibilities is to provide high-quality review of the submitted projects. The review is performed by the Expert Evaluation Committee, whose members have significant experience in the implementation of both national and international projects. The group of experts is represented by highly qualified engineers, candidates, and doctors of engineering sciences from various fields of expertise. So I think that ends up my presentation about the PromoMoon initiative and also USE Noise State Design Office. So thank you so much for listening to my presentation.
Okay. And I think it's entirely appropriate that we move to our next speaker, who's already spoken with us this morning, and that's Dallas Bienhoff. And Dallas is going to be sharing with us a really thoughtful analysis that he did to compare different transportation options for the moon. And this is the one that's supposed to be it.
Okay, thank you, John. So, good morning again. This information came out of a challenge from the Space Portal Group about a year and a half ago when we were discussing transportation, and they asked me to answer the question whether SpaceX Starship was a panacea for all things cislunar. And at the time, I had my doubts, and so I presented something to this the Space Portal Telecon about a year ago. This led into the work at the Moon Village Association Lunar Commerce portfolio that we just presented. State of that information from strictly a transportation standpoint in cislunar space. So it's not just the moon. Point in the right direction. Oh, this is the PDF version. Okay. So this is the subject matter. Let's just skip this one and not waste any time on the agenda. So these are the systems that were compared in this study. Make note that only one on this page is flying today, and that's the SpaceX Dragon. So everything you see is assumptions on launch prices and concepts. The SpaceX Starship has various implementations for cislunar transportation, cislunar landing, some assumptions along with that. The Blue Origin New Glenn, the ULA Vulcan, the Cislunar Space Development Company transportation architecture, which is something that I developed over my years after leaving Boeing, that includes space tugs and moon shuttles. The HLS landers by Dynetics and SpaceX, as well as and Blue Origin, and then the SLS and Orion. So all of those play into this cost comparison for transportation in cislunar space. Go ahead to the next slide, please. So it all starts in low Earth orbit and getting there. What is the launch price and what is the launch capability of these systems that get us out of the Earth's environment into space? So you see the payload capacity and the launch price, assumed launch price for these systems. And note I have two numbers there for Starship. The less than competitive price, i.e. cheaper than everybody else at $100 million a launch, and the aspirational or predatory pricing number of $10 million a launch, which Elon has talked about, and possibly as low as 2 for his cost. So 10 million is a low multiple of propellant costs, which is a back of the envelope number that I came up with as well, 2 million for propellant costs to launch it. So there's a factor of 4 almost, or a factor of 40 in the dollars per kilogram price to orbit in these numbers. Next slide. And the same is true for propellant. Propellant doesn't really get a full capacity to LEO into orbit because you have to account for tankage as long as it's carried in the payload bay. So I assumed an 80% factor for propellant. However, in the Starship, if it's taking up LOX methane, they go up in the vehicle tanks and it can take 100%. So it gets full capacity of propellant into Earth orbit in this analysis. And again, there's a large factor of 4 to 40. And you heard, I think it was Pete that mentioned that, or no, it was Rick Tumlinson in his talk yesterday at lunch that said a factor of 40 in the cost of getting to the moon. And then 400 if you go aspirational. So this is propellant and propellant cost per kilogram. Next slide. And the same is for people. How many people can we get to Earth orbit on these systems? 7 or 100? 7 or 100 for $90 million or $100,000? Again, quite a difference. The seat price for Starliner and for Dragon, 59 and 90 in the reverse order. 90 for Starliner, 59, and that's a seat, not a flight. So that's 90 times 7 for a full complement in the Starliner to Earth orbit for the revenue. And Starship, if it doesn't have a full load of cargo or people, it can also take offload propellant when it gets into orbit in this analysis. So that price is whether there's 1 person on board or 100 people on board per seat. So that's a flat number, independent of how many are on board, because it also delivers propellant at the same time, which is one of the great advantages of something like Starship. Next slide. So now comes the boring engineering slides, and I want to walk you through and describe the chart before getting into the details. This is a logarithmic chart. So every line is a factor of 10 greater than the line below it. And every line is a factor of 10 greater than the line to the left of it. So the curves, the solid lines are the aspirational pricing for Starship, the impact that has. And the dashed lines are the 100 million or competitive pricing, as I would call it. And really, for getting cargo to GTO, geotransfer orbit, every system smaller than Starship is the better price per kilogram version until you get above 30,000 kilograms, which nothing else can do. So Starship becomes the vehicle of choice beyond 30,000 kilograms, but from a price standpoint, smaller systems are better. Starship is just oversized for these missions to GTO unless you have large payloads that are going to that destination, i.e. beyond what the others can do. Next slide. And that holds true also for GEO missions, and that's primarily because there's no need for taking propellant to those 2 destinations at this point in time. And the next slide will show you the impact of being able to do that. These are flat curves. And this is to get into the lunar vicinity, whether it's L1 or the gateway, where there is a propellant depot. And these are flat because the vehicles never leave Earth orbit with empty propellant tanks. So if they don't have a full payload capacity on board, they can deliver propellant at the same price. So that's why these are flat. And Starship here is the better solution for any payload because of that capacity. Let's go to the next slide. The lunar surface, you see the change back to the sloped curves, again, because there is no need to deliver propellant to the lunar surface for these vehicles. They need to carry it with them until there's propellant on the surface. Starship can't take advantage of that, but that's not included here. This is as if everything comes from Earth. And again, Starship is not the vehicle of choice until you get above the capacity of the other systems. But note, the Starship can deliver almost 1,000,000 tons or 1,000 tons to lunar surface if it leaves the gateway with full propellant tanks. It is way oversized for delivering its capacity to LEO to the lunar surface. So smaller vehicles are better until you get above large monolithic payloads or massive cargo shipments at one time. Next slide. And the same holds true for seat prices. Getting a lot of people to the destination is great. Starship, flat curve, no matter how high you're going. To vicinity. Look at SLS Orion. from 1 billion to about 7 billion a seat. If they're going to send only one, but they're not going to send only one. So the input for best is 6 people. The architectural size for 6 people, and again, it's in the 10 million to a seat because of the cost per ton at the highest range. Next slide. And seat prices to lunar surface, again, the same thing. They're sloped because now you're not carrying propellant down with you to maximize the capability of the system. The Starship is clearly the vehicle of choice, independent of launch price and propellant value in the destinations. And that's because of the small size of the other vehicles, and so you have a lot more inert mass to move around relative to the number of people on board. And next slide. And then just to look at the stack of the Starship prices, to get to low Earth orbit is the bottom solid line or bottom dashed line. To get to the lunar vicinity, it's the next line up, and then to get to the lunar surface, it's the top line. And so you can see 100,000 to get to Earth orbit, about a little less than 1 million to get to the lunar vicinity, and then anywhere from about 300 million to down to 10 million to get to the lunar surface per seat, and that's per person. So that's you can get to the moon surface on Starship for less than we get to Earth orbit on Starliner and Dragon today. That's what's going to open up the lunar economy. Oh yeah, we bring them back in a tiny. These are round trip prices. Yeah. The number will go down somewhat when there's lunar propellant, if it's cheaper to get than it is to take. Okay, but yeah, great question. We do bring them back. Yeah. Next slide. For CSDC, these prices are clearly driven by the cost of getting to Earth orbit, the $50 or $90 million, unless they go on Starship for that first leg, and then the value of propellant at the high prices. So getting to Earth orbit really drives the results, and the assumptions really drive the results on this study. But Starship is a panacea for getting from Earth to the lunar vicinity, or I would extend that to the Mars vicinity in its current size as envisioned for the study. It is not good for going down to the surface because there's no need to use its full capacity of its propellant tanks to balance out that load at to the destination. Next slide. Artemis is horrendous, as you heard yesterday at lunch for those who were here. It's $1 billion a seat, according to the OIG study from NASA. $4 billion a launch, and that's just to the lunar vicinity. Getting down to the surface adds maybe another 10%. So we're not going to get there with Artemis for a sustained lunar presence. Next slide. So to wrap it up, Starship looks great for cargo launch, for people and getting them to the lunar vicinity. It doesn't look good for GTO or GEO relative to other systems unless you have very large payloads. Space-based solar power would be one of those potential customers that can really use that capacity. An operational Starship architecture from the Earth to the lunar surface and back is the lowest cost per seat, period, to the lunar surface. And then SLS Orion is really the driving price factor for the Artemis HLS personnel missions. So I will stop and take questions if we have time. I'm going to go to Peter. He was quick to raise his hand.
How many total Starship sorties are you figuring for a round trip full load on the lunar surface? And a second question is, you said that you could aggregate and land not 100 metric tons, but 1,000 metric tons with a single sortie?
Correct. I'll explain. So the Starship capacity for propellant, according to Wikipedia, is 1,200 tons. So to get a vehicle full to leave Earth orbit, it's 13 launches. One for the cargo, or one for the people, and 12 to refuel it fully. So that's 13 launches. To get from the lunar surface down to, or lunar vicinity down to the lunar surface, it depends on how much cargo you're carrying down, but it takes a minimum of 325 tons of propellant to go round trip empty in what I used. I assumed 120 ton dry mass. I have not seen a number for dry mass for Starship. They've talked less than 100 tons. I used 120 for margin. Systems always grow. There's always decreases. I don't know what it will be. So 13, if you fly the Starship with just propellant from Leo to the moon, it can deliver 350 tons of propellant to the lunar vicinity. If you fly it with a Huns on board, I assumed 1,000 kilograms per person with all the accoutrements, it can deliver 280 or so, 290 tons of propellant to the lunar vicinity. So to get to the lunar surface, it really takes another tanker load, in my analysis, of propellant, another 350 tons to top off what it is there already to get down to the surface. So it could take 13 and 12, 25 launches from Earth in order to put something down on the surface of the moon. 24 of those are propellant, which can be launched at any time because I've assumed that there's a Starship depot in Leo. So they're not on the critical path. So there could always be enough propellant on orbit to make a mission once you get the payload there. And the same thing in the lunar vicinity. There's a propellant depot in the lunar vicinity for all of these architectures, in Earth orbit for all of these architectures. So propellant's not on the critical path, but the fact that it has such large propellant, it's such a large vehicle, and the configuration is assumed to be the same for any mode of use, whether it's a lunar lander, whether it's the transfer vehicle, whether it's the tanker, whether it's the launch vehicle. I know that won't be true, but that's what we used in this study because that's the information we have that's public. And I don't have any non-public data.
I think if next answer is as long as that first answer, we have a question.
Okay, somebody.
Maybe more.
Yeah, somebody else had a question. Yeah, Madhu had. Yeah, it was a tough question. Madhu.
Yeah, I'd asked you this before. What can you tell us the state of the art in orbital refueling?
It's ready to be built and tried. It was ready in 2008 to fly and test. It has not been done yet. But there are SBIRs and STTRs and tipping points to pursue that. Okay, short enough, John?
That was good. Thank you. And I will take the chairman's prerogative, my second time in 3 days, not to ask a question, but to make an observation that it is really in this context, in the context of human settlement of the moon, it is extraordinarily interesting that the propellant of choice for Starship is methane, liquefied natural gas. This is probably, the tanks of a Starship are probably one of the best imaginable ways to deliver large amounts of carbon and hydrogen to a lunar settlement, because you're not making, there's no carbon in the lunar regolith. So you're not making a viable soil for agriculture without a great deal of carbon. Now you also need nitrogen, but nitrogen is a very nice gas to transport because you can transport it as ammonia. And I just wanted to highlight that. So for settlement, the CH4 is a stupendous payload. Thank you so much.
Good point, John.
Next, as you will have seen in the program, I am hoping you thought it was very mysterious. Ooh. We have a special announcement, which we will turn to now. Please take the podium. Something new, something novel, something unexpected. You have there. Please introduce yourself as well.
Okay, thanks for the introduction. And I just wanted to start my talk by an acknowledgement. And I would like to begin by gratefully acknowledging that the land on which we gather is the ancestral and sacred tradition land of the Tongva people and other indigenous peoples. And so I'd like to kick off my talk, and I haven't met everybody here. So I'd like to say that I'm Michael Potter. I grew up about 30 minutes from this location, and the neighborhood that I grew up in was filled with World War II veterans, with engineers, with people who worked on the Apollo program. And for many, many years into my mid-20s, I thought that was a totally normal way to grow up. Everybody, all my neighbors were aerospace engineers. And so it's no accident, maybe, that I ended up in the area of space. Some people know me from the documentary film that I made, Orphans of Apollo. And I know that some of our cast of characters are here today. Rick Tumlinson, who's been participating in the conference, was a key figure in that film. And even though that film was finished in 2008, one of the amazing things from my point of view as a filmmaker is that there was a little bit of space history related to that film, which is the Mir space station project, which came out of the Cold War. But also, try to imagine a future, which was the new space revolution. And it's just incredibly remarkable that as I stand here today to think about how that film actually foresaw so many things. I mean, basically, everybody that's involved with the new space revolution today, with Elon and with Burt Rutan and with Richard Branson, all those characters were in that film. And that's really the revolution that we're talking about today. So one of the things that I would say is that this idea that I'm about to announce, and this is the soft launch of an initiative that's been in stealth mode. So it's a soft launch to our community, the space community, which is to reach out to people to get feedback, to provide an invitation to ask people to co-create with us, which is the Lunar Museum of Art. And the presentation that we just heard about the collapsing prices to get material to the moon, that's part of that effort, which is to create something that is really the embassy for the creative envoys of all humankind. It's an extraordinary opportunity for all of us to co-create. And one of the things I would ask is, when we're on the moon, when we make our land acknowledgement on the moon, what should that say? Who are we thanking? What are we grateful for? What is it the cosmic dust that brought us all here together? And so I will invite people, because at every museum now around the world, for the most part, there's some sort of land acknowledgement that takes place. And so I think we should co-create what that acknowledgement will be on the moon and what it means to humanity. And that would be my invitation. So one aspect of creating a Lunar Museum of Art is an initiative related to the archives. And so one of the questions that I would ask people is, what should be what is the important documents, the seminal photographs, the key things that need to be stored on the moon? That's something that we'd love to talk people to give us feedback and hopefully work with people to accomplish that. And you know, it's such an extraordinary opportunity. And even 5 years ago, if you had talked about this concept of a lunar museum of art, I think 5 years ago people would think that that's a crazy initiative. And I think this is this special moment, this, you know, it's this special juncture in history that all these things come together. You know, and somebody recently told me about an epiphany that they had, and about it's about when people sit around a fireplace and they say, look, if you want to understand fire, we can speak to somebody in physics. If we want to engineer a fire pit, let's talk to the engineers. But when we gather people around the fire pit, that's art. And so I think, you know, in this industry that we're in, of course, it's very dominated by engineering and science, and unfortunately, politics and regulation and everything else. But the reason we do this is not because of the engineering. That's just to get us off planet. It's really about building communities, and it's about building those human connections. And now with the Lunar Museum of Art and an archival function, it's really about gathering those thoughts and those ideas and those inspirations together, and to hopefully be able to cherish that for thousands of years to come. And I think, you know, and that's part of the reason for being here now. The formal launch of the museum, which is being loaded right now onto a lander as we speak, and will be launched the first half of next year, is really this inspiration about again creating that platform for humanity and all of humanity's creative envoys. And so once again, we invite folks to have that dialogue, to hopefully be able to contribute, and something that will clearly last thousands and thousands of years. And if we end up with a one-way ticket to the moon, like we talked about just a moment ago, then hopefully people can stay as long as they want in the museum if it's a one-way journey. But thank you for the opportunity to extend this invitation to you, and have time for just one or two questions. So let's kick it off.
Museum of Art.
No, I'm not.
Go up there because they have ties in aerospace, and I believe that's where I heard that you've got your starter kit on art. I think there is an Andy Warhol etching or something on one of the landers up there. I don't know if it's Apollo, but it's one of the landers. Another item is I am the archivist for National Space Society, and we have a MOU with the New Mexico Museum of Space History. We've got about 130 boxes of materials stored with them. So you probably want to talk to me as well.
Excellent. Yeah, that's exactly the sort of feedback. Over here.
I have a question regarding the why a museum and not a cultural center or a residence, because a museum where we haven't done anything or almost nothing yet, like archives, I don't think it's that exciting for artists. Like we have archives on Earth and we already have a lot. Like I'm fearing hypermnesia. I don't know if it's an English word, but the want of just having archives when we haven't done anything yet on the moon.
This is part of the larger mission, and in some ways, when we look at this product, it's a little bit like what so it does other activities. And
Last question. Your microphone should be on, but
Delphin's question, Mike. We've been talking about this for some years, and I always remember the quote from somebody who said that one person's architecture is another's detail. So, so everything fits in. Thank you, Michael. Thank you.
One of the things about this conference is that, you know, there'll be a lot of and and we want it to be diverse. One of the
thank you so much. Now we're going to take a 10-minute break. As we've discussed already during the course of the week, we are on conference standard time. So it is now officially 10 a.m. Pay no attention to your watches. But we're going to get together in 10 minutes. So that'll be at just about 10:20. Real time. Thank you.
Testing 1, 2, 3. See if I can get the modulation right on this. All very much for the opportunity. I'm Gary Barnhard. I'm the president of Extraordinary Innovative Space Partnerships, Inc. We are in the mission development business. Not the easy stuff. Hell, if you can get somebody to write you a big check to go do something, have at it. It's a whole hell of a lot easier. But when you've got to start working general problems where it's really a question of, in a lot of cases, stranded intellectual property in tech on the wrong side of the technology development valley of death. You've got to take different approaches to making stuff real, and that's what we're about. So what we're going to be talking today is our work on end frequency agnostic remote power and ancillary services. What this comes down to in terms of a commercial play, it's the genesis of the Lunar Power and Light Company. Next slide, please. This is not intended to scare anybody, okay, but there's actually a very detailed presentation which will be included as part of the proceedings, but there's about 14 slides which introduce it, which is what I'm going to talk to. And what we're going off and doing, trying to provide the strategic motivation, what the key considerations are, and the path to why we think that it makes sense to make the Lunar Power and Light Company real. Next slide, please. It's sad that this is on such a small screen. It's actually an ultra high resolution visualization of the different arcs of opportunity associated with power and ancillary services beaming. Starting off with the ground technology development work, to space technology development work, to demonstrations, to deployment opportunities across 3 different arcs: space to space, surface to surface, space to the moon and asteroids, and eventually space to Earth. The intellectual conceit that I'm working under is, more than almost a decade and a half ago, I was up on stage with Pete Warden and I shot my mouth off as an engineer saying you could do something real with power surfaces beaming technology, at the very least in the space to space venue now. Okay, being an engineer that really, really wants to be right, even if I have to eat a whole hell of a lot of crow and learn a lot to get there, I decided to put my money and my time where my mouth was in those regards. And the genesis, that was the beginnings of Xisp Inc. Next slide. Basically, what we're trying to go off and do is this notion of finding nexus. Nexus in this case, we see as the intersection between the theoretical constructs of knowledge-based systems and space systems engineering reduced to practice. We're not talking about running another sandbox, for God's sakes, okay? We're supposed to be doing something. If we're going to make this lunar development real, we've got to get into this. Okay, our mission development efforts can be viewed as a set of conceptual threads intended to draw out the confluence of interests needed to bias work towards better outcomes. The process goal here really is to reverse engineer the desired outcomes. Next slide, please. What I alluded to earlier about intellectual property stranded on the wrong side of the technology development valley of death. Our approach to deal with that is what we call technology demonstration, development, demonstration, and deployment missions. And the notion there is that if you go through and aggregate the intellectual property associated with a particular problem set, figure out who thinks they own what constitutes the public domain, and who cares about it, you can define some number of missions where for each increment of resources you put into it, you can get something out of demonstrable value that one or more other missions will actually use and hopefully help pay for it. And in so doing, you can bridge your way across the technology development valley of death. Next slide, please. This is the core mission set that we're working on from an Xisp Inc. standpoint. The of which you see the space solar power and ancillary services beaming is one component of it. Central to all of this is this notion that if you can cast anything in terms of a process flow control problem, you can start building what amounts to being near real-time state models of systems and get some potential traction in a lot of these general areas. Next slide, please. In terms of power and ancillary services beaming facts, this is not science fiction, folks. Although when I started beating this drum in particular, there were a lot of people that thought I had clearly gotten into the fiction business. If you put enough energy in, to get what you need when and where you need it, you're in a better shape. The physics is frequency agnostic, but the systems need to be optimized to use. The efficient delivery of power and ancillary services is a complex systems engineering and economics problem. In terms of power beaming services, we're no longer just in the lab. Field demos are in work across the globe at this point. We need to be scalable from less than a watt to gigawatts. We require near real-time link characterization to make this stuff work, and we require the ancillary services for control. And beyond all else, we actually have to meet customer requirements. Next slide, please. Our hypothesis is that we can reduce and reallocate systems complexity, mass and/or volume. We can provide for dispatchable energy transfer. We can reduce, eliminate, or deconflict power and ancillary services requirements. We can provide necessary ancillary services. We can manage better environmental interfaces and enable more practical electromechanical interfaces and foster the identification and the use of synergies with other systems. Next slide. When we talk about power and ancillary services, what we mean by ancillary services are communications, command, control, telemetry, payload data transfer, time, navigation, when and where they're needed as an essential element to make this work. And bootstrapping power and ancillary services entails that each increment fielded must meet the needs of the present as well as serve as building blocks for the next increment. It's critical that we determine what the increments of scalable, interoperable modular power and ancillary services needed are. Next, please. Okay. The current state of the art with respect to providing viable power and ancillary services beaming to customers is effectively the null set. We have to change that. The necessary work to build viable end-to-end beaming systems is not new physics. It's a complex systems engineering integration challenge and an economic one. While there are multiple terrestrial and even some space qualified technologies that could be leveraged, the systems engineering are the same as nascent as an end-to-end system. Next slide, please. What we're dealing with, is this notion then that, power and ancillary services beaming presents as an unsolved problem in solution space. Our mission development effort seeks to address this by generating, curating, intersecting, and converging multiple technology development efforts across many different organizations and entities to yield a recommended set of deployable power and ancillary services beaming interface payloads. Next slide, please. How am I doing time-wise, John? Okay, all right. In terms of orchestrating the solution space, it requires end-to-end systems. We believe that the work of that orchestration should be frequency agnostic in terms of bringing things to the table. The work should retire and buy down both real and perceived risks, and the work should be scalable. Next slide, please. The our power and transfer efficiency, is a calculable thing, both on a piecewise basis and the end-to-end systems, which we have to address. And we also need to factor in that the electrical and thermal outputs can provide value in any context and venue. So it isn't just electrical power, okay? It's thermal energy as well. Next slide, please. Where we look at it from the standpoint of there's commercial driven applications as well as government driven space applications. I'm a firm believer that having the commercial take point ends up making the most sense. The role of government should be to help accelerate activities and add more milestones and provide additional context, but they shouldn't be who makes the railroad happen and keeps the trains running on time. Next slide. So what we're going to go off and do here is, it's great to set the strategic context, but how in the hell do we get there? Okay. We proposed initially, with respect to the space-to-space stuff, what amounts to being a CubeSat demo that shows that you can do the stuff for real, not a high power, but that we can do the near real-time characterization. You can provide a source and a customer that you're serving. Next slide, please. This is, if it works, sorry, it's a version problem. There's one of the things that we ended up doing was we took this slide and we showed that we embedded LEDs into the rectenna so that you could actually see that your beam was centered. Next slide, please. And this, is an overview of the space-to-space, proposed mission with ISS. Next slide. And the detail of our transmitter. And what's going on here, as you can see, is there's an awful lot of empty space. The robotic interfaces take up more room than the rest of our equipment. And so the question is can we go through and repackage this space-to-space stuff for surface-to-surface applications and for other venues? Next slide, please. And this is accommodations on Columbus. Next slide, please. Potential accommodations on the GEM Exposed facility. Next slide. The next step then is, after you've gone through and shown that you can demonstrate the physics of what's going on in a reasonable way, is start trying to find customers, okay, where you can go through and deal with remote services to various deployables from space stations, whether or not it's the ISS or commercial ones. Basically, you can start doing something that matters to customers. Next slide, please. And this is examples of being able to take advantage of leveraging pressurized logistics carriers. Next slide. This is the CLIPS lander proposal, where we're going off and showing that if you go through and field a power beaming equipment, in this particular case, it's millimeter wave. If you get close enough, your efficiency goes through the roof. Okay, and so anything that would be deployed from a CLIPS lander, we could do nice things for. Next slide. Where does this come down to? Okay, I've set context, strategically, and I've told you that, gosh, gee, there's something we might be able to do, but I believe in putting my money where my mouth is. So I have my friend here called Tux, the telerobotic universal excavator, which is our stalking horse for customer requirements. The bottom line is, if you're going to do ISRU, or what we like to call mining, okay, on the moon, you've got to do some prospecting. One of my colleagues, Dr. Greg Baden from Penguin Automated Systems, built this as a purpose-built robot initially for undersea, surface and shallow subsurface mining of manganese modules, and it's been adapted for doing the same, for potential ice crystal, formations. And the idea is that by equipping it with a series of different power and ancillary services rigs, we can go through and start driving up the technology readiness level of the different approaches for providing power and ancillary services beaming, and help figure out not only what works from that side of things, but learn a lot about what it takes to actually satisfy the customer in those regards. So can you wake Tux up for us? Well, while Greg's working on that, we'll go to our next slide. Okay. Takes about 60 seconds for things to fry. This is an example actually of the scaled up brethren of Tux. This actually isn't a cartoon. This is a terrestrial robotic mining platform, which Penguin Automation is responsible for, along with what we call the water witch, which is a means of addressing as up to 3-meter depth, digging, as well as capturing the volatiles and taking use of what amounts to being the coal benefaction technology, using microwaves to drive out the volatiles and capture that, and taking the rest of the material for post-processing. Next slide, please. And this basically is an effort to show power beaming shows up in multiple contexts when you start talking about a lunar village. Next slide. Again, I spent a large portion of my professional career breathing life in the ISS. It has no reason to go into Point Nemo. There's a great paper I wrote for the IAC in Paris. I recommend everyone read it. I'll make it available. Next slide. And that just points out it was designed to be extensible with power systems, including solar dynamic. Next slide. The fine print. We've invested cash and in kind approximately $3 million, sticking my money where my mouth is. I'm not kidding about this stuff. I think there's something real that we can do. Next slide. We go through and we work these different increments. There is a path. You don't have to wait for the big check to start doing something real with respect to beam power and advancing space solar power. Next slide. We think that there's, we're transitioning from a conceptual mission ripe with opportunity to multiple missions with recognized standing with NASA and the commercial world. We see that there's a growing confluence of interest. We're suggesting that, our tagline, don't wait for the future, help us build it. Next slide. It's the Lunar Power and Light Company. Hopefully I've conveyed to you, not that, I'm, offering up any claim to immaculate perception, but that there's a real incremental path of substantive things that we can do to help start retiring cost, schedule, and technical risk, both real and perceived. And I like to introduce Tux, our telerobotic universal excavator. It actually climbed its first hill, climbing up onto the stage here. It is, we haven't given it a voice yet. That's on, that's on the, on the path. What you see here, though, is there's a number of interesting aspects to it. Your treads are intended to enable the application of motive force to be able to drive in to what it is you're digging into. We've got a plow that actually chops the surface to break things up. By having a conveyor that, in a sense, desilts the softer particles from what amounts to being the pieces of hopefully ice crystals, how they happen to be entrained that you're chasing after, and possibly into the bucket. This is an example of something you start off with. I call it prospecting. The mining industry has more developed terms for it. But the idea is that you start off with a small number of units that go through and make sure what ground truth is, and then you can go through, Given that, you tune up your machines to be able to deal with ground truth, and then you can deploy them in a swarm that enables you to manage the relationship between your machine, the product, and the environment, which is part of what we have to do. I believe I've burned our time.
You're way over your time, but that's
Okay.
all right.
Thank you.
I wasn't going to
again, thank
interrupt
you all very
before
much.
the toy got shown. We do have time for a question or two if anybody would like to ask Tux what he's having for lunch.
Thank you. Well, Dr. Baden is, to be thanked for this in Penguin Automated Systems. He basically had to, get his ear bent, 6 ways from Sunday by me and hornswoggled into doing this. But the bottom line is that I was able to make the case to him where he would suspend disbelief and say, maybe they're ready to listen and take this on. Okay. And I believe you have a very interested audience. Any other, Kane? Yes. Well, truth be told, I come from a Unitarian Universalist faith tradition, and we don't have any particular reservations about the difference between those two words, but point noted. I understood. I thank you for the thoughts. Any other question?
One thing that I just want to say, the power ancillary part of this that's really important is what's in this little cube here. So this cube is a piece of slag that was taken out of the Inco stockpile where I worked. We have 600 million tons of it. It happens to be what's ground up and sent to all of you as stimulant for testing out all the robots, whether it's at NASA or whether it's at Raytheon or whoever it is. But this is a different piece because this is all that slag melted into its constituent components. And what is required to do this is a melter that's going to take a great deal of power that Gary's going to need to beam to the back half of Tux when we get it set up and built.
Gary or other suppliers.
Okay. But what you see in it is essentially obsidian glass and all of the metals that come out of what would be in the lunar regolith. We do it in Sudbury, but what we get out the metal button is basically iron, copper, nickel, cobalt, all of them, and then that can get separated into the metals that are going to be necessary. But it's all going to take power. So
and one of the interesting aspects of this is the what amounts to being the crystalline or the glass brick, if you will, can be effectively interlocking Lego blocks. If we get enough power, we can do batch processing that creates these. If we get an even more power, we can do a continuous flow process. So we're not just chasing the volatiles. Okay, we're going through and can produce the bricks and cut off in that process, the metal ingots for further processing. And also, there's this weird notion that we've got an awful lot of these slag piles on Earth. It would be kind of nice if we could do something with them.
So last question, if any. One.
Check.
Thanks, Gary. This is an excellent presentation. And Greg, it's wonderful to hear more talk about power. My question is can you quantify on a high level the power that you need for both the bricks and then moving to the next stages?
The answer to that is yes. I would like to say that how we have been working that answer is that it's going to take us up to one 1 kW to see that we've got something that we're going to be able to work with. Okay. The power requirements with respect to regolith, I want to test. I don't want to scare people. Okay, the numbers are higher than most people have been talking about delivering, but that's one of the beauties of looking at things on a frequency agnostic basis. A lot of people are think very weird thoughts about W band. Okay, but if we can make that work, the efficiency goes way up. There's and really depending upon the distances, you can basically alter how close you have to be to drive the power deal. And quite frankly, as opposed to going through and getting into an argument with the nuclear folks, we have them as partners. It turns out that solar dynamic system, compact nuclear systems require heat exchangers. Thank you all.
That was when you're going to wander off into talking about the nuclear folks. I got to stop you, Gary. I'm sorry. Thank you very much. Setting aside the question of coupling and so on, the answer is about 2 kilowatt hours per kilogram on order of. So now you've got to cook that for a while, and I'll just say a kilogram of lunar regolith is a fairly small volume, and so you need a very large number of kilowatt hours to make landing pads and roads and all the other things that we've been talking about. But nevertheless, it's like 2 kilowatt hours per kilogram. How quickly you want to accomplish that determines power. But you have to have a certain amount of energy, and then it has to cook. It's like a kiln. However you deliver the energy. So you think about baking a piece of pottery, and I think Greg said before the break during the break that it's like an hour. It bakes for about an hour. So it's like pizza. It's not like pizza. You don't stick it in a 700-degree oven and then it's done. You somehow apply something like 1400 degrees and you wait. Okay. Sorry. No. Okay. It is now officially 10:30 Conference Standard Time. If you would go with, there we go. So we had hardware, we had specimens, we had a focus on a particular industrial opportunity. Now we're going to step back in the closing minutes of the workshop and symposium and talk a little more about what are the actual plans. Now, I don't know of existing organizations like NASA. Now, I don't know if you have seen the global exploration roadmap that was produced by the International Space Exploration Coordination Group, ISIG-G, in August of 2020. But I would recommend it to you if you want to look it up online. It's still accessible from the ISIG-G website. And it lays out certain goals and objectives that are internationally recognized and are germane to future lunar development activities And if you've ever done strategic planning, then you know that in principle, a good strategic planning process begins with something like a vision or a value proposition. It's what are you trying at a high level to do? And then it is decomposed or it's extracted into a set of goals. So you get a vision or a value proposition, you've got goals, things that you need to do to realize that. And then you have objectives. And the objectives lay out specifically, okay, to realize my goals, to accomplish my vision, deliver the value, these are the things that I need to go do. Now, interestingly, NASA came out late in September, the end of September, with a set of Moon to Mars objectives that were framed, and Associate Administrator Bhavya Lal explained all of this at a recent event in DC, the OffWorld Institute or Off-Earth Institute meeting. And she explained that these were framed basically by getting together a group, and I won't try to recount exactly how she described the process, but it had to do with getting together different groups from across the NASA leadership, and they each put together a set of objectives concerning their business area. And I wanted to share these with you and focus on one part in particular. By the way, this document is about 13 pages long. It's easily available online, and so I'm recommending it to you. Outstanding. Very little in here about the process. If you want to get the process, you need to go to the OffWorld. Beyond Earth Institute. Thank you. That's why I had a bit error. Beyond Earth Institute, and look at what Dr. Lal had to say, because this doesn't tell you how they made the sausage. Nice statement from Pam Melroy on what this is. It's an objectives-based approach, i.e., there is no vision, there is no set of goals, nothing beyond the Artemis plans that Dr. Clinton kindly shared with us on Tuesday morning. And then there's a set of, well, there's these recurring themes. I can use a laser. There's these recurring themes like international collaboration and partners goes on, and leveraging low Earth orbit capabilities. And then there's a set of objectives that had to do with science, lunar and planetary, human and biological, science enabling that are applied. Okay, and these are broadly in the character of use stuff to do good science, stated in a variety of ways. And this is largely because NASA's science programs, exploration, Earth, and so on, are not based on purposes stated by the agency. Rather, they emerge from collaboration with the broader science community through the National Academy of Sciences to come up with objectives based on answering big questions. Like, is there liquid water on Mars was a question, some characteristic of a question some years ago. So these, although they say they're science objectives, they're really basically use the stuff to do good science. And then the real science objectives will come out of the collaborative process with the broader science community. But there's this one, and these were come up by the space science people. There's this one later, which is transportation and habitation. That comes out of the Space Exploration Mission Directorate, HEOMD, Human Exploration and Operations Mission Directorate. And there's operations. So this is the human exploration, it's transportation, habitation, and there's operations. And these have to do largely with the plans that Dr. Clinton outlined for Artemis and related things. But there's this one, which is really interesting, which came out of STMD, the Space Technology Mission Directorate. And these are for the purposes of this workshop and the Moon Village Association and the community that's interested in space settlement more largely, the most interesting. So the first one, and these are impossible to see. I don't suppose there's any way to enlarge the size on this text, gentlemen, in the back? Is there any way to, I know this is on the screen view, but there you go. That's a ticket. Thank you so much. Okay, thank you very much. So, and this is directly relevant to what Gary was just talking about and what a number of us are also working on. So it makes a very nice sequence of events. Develop an incremental lunar power generation and distribution system evolvable to support continuous robotic human operations and capable of scaling to global power utilization and industrial power levels. And as we talked about yesterday, that's megawatts and more, if those words mean what they actually mean. So although there is no vision, there's no value proposition in national policy, there's no goal to do lunar surface industrial development. Nevertheless, an enabling capability, i.e. power, generation and distribution, evolvable to global scale and industrial power levels. And so as an objective, just published by NASA, it is extraordinarily consequential. And it builds on things that were in the earlier global exploration roadmap from the International Space Exploration Coordination Group 2 years and more ago, but even bigger, even bolder. In that case, they talked about doing ISRU and they talked about power at about 300 kilowatts, but they terms like this. Develop a lunar surface orbital and moon to Earth communications architecture, scaling up to industrial needs, lunar POSNAV, position, location, navigation services, servicing industrial needs, demonstrate advanced manufacturing and autonomous construction, demonstrate precision landing. That one's kind of a throwaway in my view. Demonstrate local, regional, and global surface transportation for a robust lunar economy, industrial scale in situ resource utilization at a robust lunar economy, technologies for cislunar orbital and surface depots, construction, manufacturing, maximizing the use of in situ resources, and develop environmental monitoring, environmental situational awareness, etc., for continuous human and robotic presence and operations. So if you deconstruct the words, what you find is there seems to be an implied goal of a robust lunar economy underlying a number of these, and industrial needs. So if you just go through and you look for the words that have to do with why would I do this, i.e. what's my purpose, which is another way to say goal, what you find is this set of goals, and it has not, to my knowledge, been broadly trumpeted. I haven't seen any big articles on the, in the Space Review or anything like that, but it's directly relevant to everything we've been talking about over the past several days. So a robust lunar economy, continuous human presence, sounds like a settlement to me, unless you want to do it the expensive way with, like the space station. So robust lunar economy, so continuous human presence, industrial activities, including power, transportation, surface transportation, comms, navigation, ISRU, manufacturing, construction. So sort of just out there, tossed into the water in the middle of the month of September. There is this fabulous statement of objectives that are very much directly related to lots of things that this community cares about. And I wanted to highlight that during this conversation because again, it's directly related to the lunar commerce portfolio. It's directly related to many of the talks that we've seen about rovers and power and all these other things. Yes, Bruce. No, it's only been out for a month. 6 weeks. It's been out on the test table for about 6 weeks. Whether or not money will get allocated for it, I think is an open question. But it is, I think, fairly clear. And whether or not it endures, it's definitely the vision of the Space Technology Mission Directorate and its leadership and the people who work with it. Whether or not it has the backing of HEOMD, the human exploration part, this part, the people who are doing sorry, I've got it. No, now that I'm enlarged, I can't go to the next page. But it's okay. Don't do it. Don't do it. But don't do it. Just go ahead and go back to Zoom. But there's a question about whether or not it's how broadly NASA as a totality, all of the NASA leadership supports these goals and objectives. But it's really clear that it's a powerful statement of the more advanced thinking part of the agency. Yes.
March storm. I'm wondering if the NSS might consider making this like the one thing to really focus on with, senators and House representatives when they do the March storm this year.
Yeah. Well, I think that NSS. This is an NSS question, not a MVA question. But MVA does not engage in trying to influence American political and policy decisions.
Mm-hmm.
We are an international organization based in Austria and Vienna. We don't do that. I personally would just comment that I think March Storm has tended to focus on other kinds of objectives, like space settlement, that underpin, like there would be goals in the context of this document. I think it'd be messy to try to support precision landing as a focus of March Storm.
Well, I meant just generally.
Oh no, I understand.
Industrial
But
buildup.
and I wanted to highlight. Was there? Yes, Dallas. Shout. Yes. These mics are awful.
To Bruce's question, is there money behind this? I would suggest that anybody submitting proposals to NASA, whether they're SBIRs, STTRs, or other proposals, that they link their project to the right objectives in this list.
Yeah. And if you look at the past technology roadmaps from NASA, they have tended to look like shrubberies. There are so many individual technologies and so many individual goals and objectives and so many that there's no root and trunk and branch and twig. There's this organized hierarchical way where you can say, I'm going to do this because it is the critical thing for this over here. It tends to be far more broadly based where everything is roughly equal. This at least is a fairly concise statement of 9 lunar infrastructure objectives. Now, and then the other ones, the Mars infrastructure objectives, again, power to an initial human Mars exploration campaign. Doesn't talk about human settlement, doesn't talk about industry on Mars, but it does talk about industrial development for the moon, and comms and POSNAV and ISRU, but for the initial campaign. I think this is extraordinarily reasonable on NASA's part. The moon is within our programmatic grasp, so to speak, as an international community, whereas doing large-scale activities with regard to Martian infrastructure is still almost certainly more than a decade away. So it's not an unreasonable perspective. Any other questions? Please.
is that I come from a completely terrestrial business, which is the mining business. And this cleanup is going to happen on a global basis. And there's a way that I see to tie what's going on in space to what's happening on the rest of the planet in terms of having to clean things up. And I think the synergies of getting this group involved in the current global issues of cleanup of mine waste or cleanup of industrial waste and all those things as a result, as an outcome of working jointly with NASA, with NSS, could raise the prestige of this whole organization substantially in the world.
Okay. Dale.
International organization. Moon Village as an international organization could put some backing behind NASA saying that our country thinks this is a good thing. Our government is always interested in international partnerships and such. So I think there is an angle on there where you could do something.
Well, we can do education. We do educational things. We don't try to influence policies. So we can certainly do education. Madhu?
John, I'm sure you know this technical memorandum from 1989, which looked really, which NASA looked at really all about the moon. And I think it was TM 4078 or 4075. But anyway, my question is, how nebulous is the Mars goal when you mix it up with a more concrete lunar plan? And how does it impact the way NASA does their work, at least from the outside? You may have some thoughts.
Well, I think that over the past 5 years, there has been considerable evolution, and I would say almost like fractionation, to use a petroleum processing term, among different individuals within NASA, and I'll say within various space agencies. Whereas on the order of 5 years ago, we were all on our way to Mars by way of a quick stop at the moon. Several years before that, we were all going to Mars together by way of a quick stop at an asteroid. And to settle down and have a significantly greater emphasis on the moon is still a relatively new thing. And there are still lots of people who, and as you can see in the official plan for Artemis, who want to get on with going to Mars, who don't really want to get stuck, as was alluded to in our conversation on Tuesday, don't want to get it stuck on the moon. And it's sort of like saying, I don't really want to get stuck in California. I mean, God forbid I go to California and I become wealthy and I raise a family and I have farms and vineyards and mines and factories and cities, and I don't want to get stuck there. I want to get on to Asia, which is where I was really going. I think it's a misconception to think of the moon as a place where you get stuck. I like the characterizations we've had earlier in the conversation, but right now the agency is divided into several fractions: the science focus, and the same. Like I said, I would say the same thing is true among all the major space agencies. It's science focused, or it's human spaceflight focused, the current program portfolio, or there's some that are more on the future and development and industrialization and utilization of space. But there are these collections of interest groups. So, and that's just going to persist. Gary, I think, what did Madhu, did you have the mic? Oh, you gave it up. That was very good of you.
if what your end product is what we used to call view graphs or PowerPoint presentations, okay, you can tell that story with a different with a different set of charts and a different set of objectives, and you don't have to do anything, or at least nothing that is going to severely challenge you. Okay, the where we are with respect to the lunar stuff is you can't jump up and down and wave your hands about how wild and sexy and fantastic what you're going to do is if you're just going to have somebody show up again for a few days. Okay, you actually have to do something, okay, to make it real. So their notion that there's some kind of bifurcation there, may not necessarily be driven by insightful programmatics. It may be driven by
it's
we
just
don't-
momentum. It's just
Yeah.
momentum. It's
Yeah.
it's not as has been pointed out before, it is not sustainable to envision a future on the moon where 4 people go once a year or once every 18 months at a cost of $10 billion a year plus.
Right.
That's just not because the public, and especially the younger public, won't waste their money. So,
But if we can actually figure out how to drive the wedge from a commercial perspective, we may not be able to change the nature of the bureaucracy, but we can encourage it to do better things.
yeah, Bruce wanted to say something. I'm sorry.
Yeah, I guess maybe one of the things that we could do that would actually add value here is because we've been talking about, leveraging the moon to go to Mars for decades now. And, and I think what we're running up against and what you were alluding to, John, was that a lot of people don't believe that, they view the moon as the tar baby. And there's a reason for that is if you look back at NASA's history, when Apollo was over, the only way that we got the resources to do the shuttle is you had to deep six the Saturn V. And then when when you wanted to do the space station, we kind of used rather than doing what would have been logical, which was developing a new heavy lift launch vehicle, we decided, no, we're going to use the space shuttle thing. And 30 launches later, you kind of have a space station up there. But I guess the thing here is could we, as a community, one, look at making that real, that, we really are going to learn things here. And the number 2 thing, which I think is even more important, is the economics of this, is that the other piece of that puzzle of sustainability, not only can it cost $10 billion, is you better find a way to make some money out there along
Could I
the
go to
way.
my next slide deck? I don't mean to, please let me just interrupt. Could I get to the next slide deck? My next one. I know you're partner in crime Vantage, but it's germane to Bruce's point.
Okay, and I'll shut up now.
I wasn't trying to get you to shut up. I agree with your point. Oh, Al, you?
I just wanted to, everybody's talking so dirge-like tones, like, oh, it was so awful. Those guys want to go to Mars. Things are going great. They're going really, really well. We have 5, 6, 7 vehicles under development, fully reusable launch vehicles. We've got several companies on the ISS trying to produce products, and they're having some success, not a whole lot, but some. We have 4 space stations funded by NASA in development, and many more that aren't funded. Things are going really, really
I wasn't
well.
speaking in dirge-like tones. I was talking about how marvelous these objectives are.
You're the exception.
But I'm on the stage.
Yes.
Okay. And I wanted to come back and highlight one of the major differences by way of introducing our final topic. We have about 20 minutes before we're going to take a break. When we take the break, we're going to, can I click on this one? Okay, cool. We're going to take a break at 11:45, and they're going to set up this room for the luncheon. All the rounds will be fully populated. You'll need to leave your tables in a nice, neat configuration, or they're going to put plates and napkins and silverware on top of your computers. I understand we don't have to get everything out of this room, but I might recommend that you try moving your things sort of to the side or in a neat pile, or put them on a chair, or do something. Don't leave them the way they are right now in front of you, because we won't be able to eat. Okay. That's the answer. And this is the question. So why are all these space agencies, and they all now exist, and there's more than these, and all the companies that underpin all of them, and there's more than just the space companies, there's terrestrial industry. Why is this all happening? That's the answer. It's because over the past 20 years, we have discovered and confirmed that there are significant resources in the form of lunar ices at the poles of the moon. And you can see the impact of this discovery and validation in the cadence and the diversity of lunar activities. And so it's not the same situation as it was in 1989 or 1973 or even 2005, where we got some kind of lunar program, where we got some competition between lunar and infrastructure and so on. And there's not two superpowers racing to the moon. There are dozens of countries and scores upon scores of companies all developing technologies and systems to go to the moon, and they're doing it based on this vision as articulated in a lunar economy, a cis-lunar space economy. And I think it's just taking the official space programs a little while to catch up with that. It's only in the last 5 or 7 years. It's a combination of this reality and the development of the new launchers, as Dallas was describing earlier this morning. And that the combination of low-cost access to space, not with one launcher, but with many by the end of this decade, and resources, and diverse and flexible and immense competition and interest and investment. So I wanted to come back to this idea and talk about it just a little bit with the larger group. So we've been doing this case study since 2019. It got started, the OASIS 2045 case study got started because at the last MVA meeting, workshop and symposium in Asia, it was in Tokyo and Kyoto in 2019. We had a breakout session for the architecture working group, and frankly, I had an epiphany. And my epiphany was exactly what Dallas described with numbers today. But I will just take some credit. I had the epiphany without the numbers three years ago. And that is that low-cost access to space, to LEO, is going to change everything in cis-lunar space. And I'm not talking about going from $20,000 a kilogram down to $8,000 a kilogram, but rather going from $20,000 a kilogram down to $2,000 a kilogram, and then on down to a few hundreds of dollars a kilogram. And that is just gonna change the world. Yes, Greg. Right.
There's other new things that are being found
all the time.
And one of the reasons I want to emphasize blue diamonds is blue diamonds are harder than the current diamonds that are synthetic made. And those are the keys for diamond drilling and exploration all around the planet. And so that's why the Chinese are there. They're looking for these other things. And so to just say it's water is not right.
No,
and
but it's not true, but it was the catalyst.
No, I agree completely. Okay. It's the catalyst.
Yeah.
But the other thing that has not yet been done by anybody is to actually put a proper drill hole in the moon.
Okay, I don't want to go back to that. I don't want to get back to that level of detail. Please forgive me, Greg. We were there earlier, and we can come back to that in discussion. But okay, very good. So, yesterday in the breakout session, we talked about a lot of this. This is the framework for the OASIS 2045. It's the lunar South Pole. It's the first permanent human sustainable settlement on the moon. The case study looks at a particular location, which is one of the ones that Pascal Lee indicated is desirable. One of the three that are the most desirable, as I recall. In his assessment, it's at the edge of two of the boxes in the Artemis 3 planning. The idea is that this would be I don't want to get into those. This would be a sustainable activity involving, and I'll do it with this metro map, involving a central habitation, agriculture, a chemical processing plant, a manufacturing center, mining done at a remote location, with, in the case of the case study to date, ore being returned, i.e. At cold temperatures, bearing water ice and other volatiles or other materials to be the OASIS location, a spaceport coming and going both from orbital nodes down to the surface and from the surface up to orbital nodes, and two locations on the lunar surface via hoppers, a lunar science station, all sorts of stuff. We've looked at a whole variety of use cases associated with the OASIS 2045. These are prospective businesses. I don't yet know, because I only just got the lunar commerce portfolio, how it maps or doesn't map with some of the cases that you've looked at. I do include in the longer term components for solar power satellites and electromagnetic launch from the lunar surface as parts of one of the longer term use cases for the moon, where longer term is not driven by technology but just by economics. And there are some, I think, important aspects to consider. This is not an illustration of the OASIS habitation system. This is an expression of philosophy. So all the cartoons that you probably have seen about lunar bases or lunar outposts or lunar camps, or what you see a nice flat plane where somebody has brought something and they put it down, and then they've covered it with dirt, or they've covered it with sandbags, or it's more fanciful and they've just got domes that don't have any kind of radiation shielding at all. The concept that has been explored in OASIS 2045 is basically like cliff dwelling. Humanity has been doing cliff dwelling since the age of the Cro-Magnon and Neanderthal neighbors next door. And so it's a very old form of human habitation, and it provides a great deal of shelter. This happens to be a cliff dwelling from the Anasazi people in the American Southwest. And it's a combination of carved cliffs, dwellings in the cliffs, and stone block constructed or adobe block constructed structures. And this is the model for OASIS 2045, with an exception being, but then you also have to have agriculture. So you have to have, and in this case, the concept for the agricultural greenhouse is this spiral, where every one of these, can you zoom in on this? And then over to the, there you go. But zoom in, there you go. Okay, and then out a little bit. Oh, that's good. That's good. Thank you. So the idea is that each of these segments is about 1,200 square meters of farmland. And it's set up as a series of modules so that you could take a meteorite hit on one of the pressurized segments and it wouldn't do anything to the rest. So this is like the shell of a nautilus. It's a series of pressure vessels arranged in a spiral so they support one another. And together, if you count the number of pressure vessels, each one corresponds to one person. So there's a natural synergy there. And one of the ideas that I've been thinking about over the last several months is this question of how the system architecture corresponds or enables governance models and economic models. And I wanted to tell you about this to invite your thinking about it and to providing thoughts on how this idea might develop further or not. I had a question posed at a session recently. I don't think it was you, Peter. Maybe it was you. No, it was somebody else. I think it was somebody else. But in any event, the question was, well, what if they don't want freedom? And I said, well, you know, that's too bad. Then they can go someplace else and start. So what I described was a governance model for OASIS 2045, which is based loosely on the Mayflower Compact, or the land grants and the land organization around the joint stock companies 420 years ago. 400 years ago? 390 years ago. The Virginia Company, for example, where each of these would be owned by a citizen. And you build them out, and every citizen has a farm. They have a farm. This is like a village in the medieval era. There's some common space in the center, so the commons. And there's a hotel, and there are those things too. But it's not a company town in the sense of a large-scale 19th century mining operation. You know, the song, you know, I dig 16 tons, and what do you get? Another day older and deeper in debt. And this was the thing that I was struggling with, is how do you have a model for the system that leads to equity and equality and democracy and liberty, rather than a company owns the whole thing and you are owned by the company. That's a dystopian view of space settlements. And I've been thinking a lot about how to avoid that. And so the idea here is you start with one, and then you add another, and you add another, and you add another. And over the course of time, you fill out your crater where you've got good radiation shielding and so on. And that's how many people can live in this particular settlement sustainably. Would you go to the smaller size so that I can click again? Okay, and I want to go back to this one. So, and in this region, right next door, there's a perfectly good crater where you can do the next one. And nearby, over here, there are more places where you can do more. And over here, so the idea is that you could basically develop that city through a series of neighborhoods. And the neighborhoods have a certain amount of self-reliance, they have a certain amount of modularity, they are reasonably robust, and they are fundamentally tied to landholding, to farming. And the farmers make the fresh air that would then be sold to the tourists. The farmers, this farmer in the sky, following the Hanlon model, the farmers own the means of production, not as a communistic thing, but rather as a joint stock ownership idea. And that way you don't work for the company and the company sells you your air and sells you your water and your food, and you never get free of your debt. But rather, you're one of the owners of production, and then taking that term deliberately. And then the question was posed at the IAC by somebody. I think it was at the IAC. Anyway, well, what if they don't want to be free? I said, then what do they want to work for the company? I said, okay, they can go to this other crater and they can start their own place, and that'd be fine. But for this purpose, this will be made up of free landowners. And so I'm introducing that as an additional aspect of OASIS that links the system to the business model, to the governance model. Basically, the different breakout sessions that we've had this week. And I would like to invite all of your thoughts and inputs on this idea, because it seems to me that we somehow have to consider how all of these aspects of a lunar settlement either work together and succeed together or don't. Thank you. Please. Presumably, they do it because their children want to move back to Earth.
So I got a couple more models for you. So honestly, the model you really are talking about here is pretty much a Midwestern farm, smallholder farm town. So Camp Point, Illinois, perfect example of what you're talking about. It's where my grandparents used to live, right? So it's the same exact concept where you have a series of small farms that have self-organized.
Yeah.
Essentially.
Well,
and in the center of town, what do you have? You have the church, you have the farmers
absolutely,
co-op,
absolutely.
right? So
It's a medieval Europe without the Duke.
Right, and it's slightly more modern. I mean, you could also, though, an alternate model might be something more like the Hawaiian Polynesian model, right, for how they did their terrace farming. Just a thought.
Yep. No, please, thank you, but don't just share it verbally. I'm trying to get everybody to start thinking about this and contributing to this idea. But Dale and then Dallas.
I think I can talk loud enough anyway.
No, it's for the online. We've only got 3 minutes, and then we have to stop so that they can set up the room.
Okay, total support for your idea of the small holders. I'm curious, do you have a preferred model of the community doing debt financing or a joint stock company in order to, it's expensive setting up a farm, and it's going to be even more expensive on the moon. So do you have ideas on the financing of that?
Not yet. So, and I bet you it's going to be a mix of means. Could even be a global lottery. And you put in we all had $1 billion win just the other day. You put in your tickets, and if you win the OASIS lottery, your freehold gets funded for the next time. And of course, other people get half the money if they want. No, Dallas was next.
Dallas.
No stealing the microphone, Madhu.
I'm sorry, he was close to me.
I bet you were a terror at the dinner table when you were young. I'm sorry, but that the rice was close to me.
No. In his defense, it was handed to him. He didn't steal it. So as long as you're following Michelle Hanlon's guidelines, where this is a guidepost and not a dictum.
Yeah.
A dictate, because people will govern themselves independent of what
Absolutely. But my purpose is only to do a case study. And though this would be an example, it's not it's just an idea. It's just a guide. Yeah.
John, as a faculty member in the School of Architecture at USC, I just completed a talk on city planning because they wanted to know what space and space technology could offer people on Earth. And we may have some feedback on your suggestions. But my thinking about city planning in our world over the last 5,000 years flies in the face of your design, but we'll have to talk more about this. in how it's done.
No one lives in a vacuum on Earth.
That's right.
So
Vacuum.
this is
part.
designed for safe, effective, and growable vacuum living.
Absolutely. Okay, good. Anybody else?
So I have one other, if there are no other comments on this, I had one other tidbit just to share, which is short. And it has to do with this structure, which is the city hall kind of place, which would be about 50 meters in diameter. And I want to remind you of an image from the movie 2001: A Space Odyssey, in which there was the large sphere at the front end of what was the name of the spaceship? And our hero was running around the volume. And I wanted to mention, so if you had such a volume on the moon and you have a cylinder, simple cylinder, and it's like 40 or 50 meters across, in point of fact, you can pretty much ignore lunar gravity and just run around the wall and have 1G at about 4.5 kilometers per hour pace. So just a little faster than jogging. So for lunar artificial gravity, although we saw some beautiful visions earlier, you don't actually have to have elaborate machinery. You just need a large annular space, and you can just run. You just run, and it's 1G. Or you can run a little faster, and it would be 1.2 Gs. Or you could run a little slower, and you could still stay on the wall, and it would be a little less than 1G. So, but you just do the vector force diagram, and the difference is negligible, a tiny fraction of a degree in terms of your angle. So I wanted to share that as a fun idea. Okay, we are at the close of this morning's session, and we have a luncheon program which will highlight a couple of important announcements, the most important of which will be the announcement of the 2023 location for the MVA Workshop and Symposium, and an introduction of the NSS Space Settlement Summit, which Dale will make. He doesn't know about this yet, but I'm just mentioning to him that I plan to call you up on the stage, and that's our transition point. And now we need to close and have the room prepared for our luncheon. So I'd like to thank you all very much.